So we're on page 137, section 5.4, solving special systems of linear equations. Let's get into it. So we already learned the three methods: graphing, substitution, and elimination. And so we're not learning anything new as far as how to solve, but we're looking at what the solutions might look like. So if you look at this, we see that there's one solution where they intersect. This is pretty much everything we've done for the past three sections. Now, the focus is mostly on these two. These are the special cases. So if you have lines that are parallel, well, the definition of parallel is that they don't intersect. So if you look at these lines, you'll see that they don't intersect, then there's no solution. What will that look like when you solve it by substitution, or when you're graphing? You'll just see, oh, they have the same slope, so they won't touch. When you're solving by substitution or elimination, that will look a little different. We'll get into that. In fact, you'll get something like nonsensical. Actually, it'll be really simple. You'll get something like 5 equals 3. And you can say, oh, well, it's obvious that 5 is not equal to 3, so there must be no solution. On the other hand, if there are infinitely many solutions, you'll get something like 5 is equal to 5. Oops, 5 is equal to 5. You'll say, oh, well, 5 is always equal to 5. So this is infinitely many solutions. We've definitely covered this before, but I can't remember which section, so whatever. We'll apply it to this. If you remember it, good for you. If not, well, we'll basically relearn it. So in this picture, the lines are the same, which means they're always touching. So here they touch once, they intersect once. Here they never intersect, and here they are always intersecting. Always meaning forever. So that's why the lines are the same. Okay, moving on. Solve the system of linear equations. So I will show you how to kind of like here. Actually, let's plug these in by graphing first. So one is y equals 3x minus 7. And the other one is 3x plus 4. So if you look at these lines, you'll see, if we zoom out, you'll see that they never intersect, right? But that's by graphing, and there's no graph here, so I'm just showing you for the sake of showing you. And anytime you have anything you want to graph, Desmos is always a great time or a great way to check your answer. So we can already see that there is no solution to this. But how will I prove it? Here's another way. So let's say we go by subtraction. So let's subtract this, or sorry, solving by elimination. So I have y minus y, that's nothing, so that's 0. I have 3x minus 3x, that's also nothing. I have negative 7 minus 4, that's negative 11. Boom, that doesn't make any sense. So what's the solution? No solution. That's elimination, and oh, let's try substitution then. So if they're both equal to y, that means I could set them equal to each other. So instead of y, I know y is equal to 3x minus 7. I'll say 3x minus 7 equals 3x plus 4. And then I could subtract 3x, I could subtract 3x, and then I get something like negative 7 is equal to 4. Negative 7 is equal to 4. Again, this is a nonsensical. This just doesn't make any sense. Negative 7 is not equal to 4. Otherwise, it would be negative 7. So, boom. So you could solve any method, graphing, or not graphing. There's no graph for you to do here. Elimination or substitution. If they're not equal, like you just get some nonsense, that means they are no solution. If you get one x and one y, that's one solution. And then if you get something on the other that is just like always true, like 10 equals 10 or negative 5 equals negative 5. That is all infinitely many solutions. Let's try this one again. We're going to eliminate y minus y, 0. Actually, I'll show you guys graphing again. 5x minus 1, negative 5x plus 5. Dang it, 5x minus 1, negative 5x minus 5. Oh, sorry, negative 5x plus 5. 5x minus 1, negative 5x plus 5. Here's a point of intersection, 0.62. They connect. So I will do that. We know that there is an answer, right? Also, I forgot to mention, if they're parallel, they have the same slope, right? So if you notice that they have the same slope, then you should realize that they're parallel. If they're parallel, there is no solution. Anything that is not parallel, so like 5x and negative 5x, is probably going to have a solution. So let's work it out. Minus 0. 5x minus 5x, negative 5x is 10x. Negative 1 minus 5 is negative 6. Add 6. Add 6. 6 equals 10x. Oh god, that's hideous. Sorry. Divide both sides by 10. 6, or sorry, 0.6. Let me erase all that. 0.6 equals x. And you guys know how to get y. You take it, go into any of the original equations, and you solve for y. You plug this in for x. Okay, let's see. 2x minus 3y. Okay, I can't just easily pop that into the calculator because y is not by itself. So let's just get after it. Add them together. 2x minus negative, or sorry, 2x plus negative 2x is 0. 2x minus 2x is 0. Negative 3y plus 3y is 0. 10 plus negative 10 is 0. 0 equals 0. When you have something like this where it equals itself, if you have one solution, no solutions, or infinitely many solutions, the answer is infinitely many solutions. They are the same line. All right, that's it. So those are your 3 examples. Everything else you will solve exactly the same way. If I had to go back and give you some notes, these are the notes. So we'll just back up by 1 page. One solution equals 1 point of intersection at x, y, whatever it is you get when you solve. No solutions equals lines are parallel. They have the same slope. Example, you might get something like 5 equals negative 3, which makes no sense. Infinitely many solutions. Lines are the same. So lines are the same. They also have the same slope, but not only do they have the same slope, they also have the same y-intercept. Lines are the same. They are always touching. Example, negative 3 equals negative 3, which is always true. All right, guys. So those are your notes. I give you your 3 examples. Let's see if there's anything else I need to cover. That's it. Number 19, you have $15 in savings. Your friend has $25 in savings. You have both are savings. So here's you. Here's your friend. You have $15. Your friend has $25. You both start saving $5 per week. So $5 times the number of weeks. After 1 week, you have 20. After 1 week, he has 30. Equals total. Equals total. So if you look at this, I mean, it should be pretty simple, like just conceptually. Okay, first you start off with 15. He starts off with 25. You both start off. You both add the same number each week. 20, then 30, 25. 35, and you started off $10 behind him. After 1 week, you're still $10 behind him. After the second week, you're still $10 behind him. If you can't tell, you're never going to make any progress. So what does that mean? No. Will you ever have the same amount of savings as your friend? No. If he or she is already ahead, and you keep adding the same amount, you will never catch up. In order to catch up, you must save more than the friend each week. You know, like if it was $6 and the other guy or girl was only saving 5, you'd have 21 here. Plus 6 is 27. Plus 6 is 33. So you go from a deficit of 10 to 9 to 8 and then 7. You know, but alas, when there's only $5, you'll never catch up. All right, guys, that's the lesson on solving special systems. You have one solution in the previous sections. You have no solutions. You have infinitely many solutions. If you have any questions, ask your teacher or let me know.